Now that we've worked on our formulas, we are going to look at how we might use those formulas with specific examples. So if I have f of x is equaling to 3 times sine of x, I'm going to start with f prime of x equals 3 is a coefficient, so I can do 3 times our derivative of our function sine of x. So 3 can kind of stay where it's at. The derivative of sine of x is cosine of x, and there's nothing I need to simplify, so I can just leave it at that. For g of x equaling negative 4 cosine, though, I can do g prime of x equals negative 4 can plop down like we did with the 3. The derivative of cosine, which is negative sine of x. We can simplify this by multiplying those two things together. So negative 4 times negative sine of x to get 4 sine x. E to the x is my all-time favorite derivative. So when we look at 17 e to the x, just like the other ones, 17 is just a coefficient up front, so I can do 17 times the derivative of our function. So 17 times the derivative of e to the x. The derivative of e to the x is just e to the x, so it's literally 17 e to the x for both the derivative and the original function. Natural log is pretty similar in kind of just like ease of use. So 13 is going to be the first thing that we have here, and the derivative of natural log is 1 over x. I can change this to 13 over 1 and then multiply straight across, so I get 13 over x. E to the x and natural log are generally more seen than most other things, but we can still see these other ones from time to time when we're looking at stuff. So 4 to the x power, if I want to take the derivative of it, just like e to the x, 4 to the x is going to be a part of it. But because 4 is not e, we have to include and multiply this by the natural log of that base number, which happens to be 4. And that's our whole derivative. And last but not least, the log base 7 of x. If we were to take the derivative of it, just like natural log, we get 1 over x. But we also need to divide by the natural log of our base 7, which would be similar to doing e to the x. This comes from this thing called change of base. So if I have log base 7 and I didn't like the base of 7, I could change that to something else, which would be something like the natural log of x divided by the natural log of 7. Because I can rewrite this as 1 over the natural log of 7 times the natural log of x, and I can take the derivative, well, 1 over the natural log of 7 is a whole, it's just a number, so this is a constant, and a constant times the derivative of natural log would be 1 over x. So if I wanted to take the derivative of this, it would look like 1 over natural log of 7 times 1 over x. And if I multiply those together, you're going to get exactly what we have over here, which is 1 over x natural log of 7, or 1 over 7 natural log of 7 times x. So there's always a rhyme or reason to why it is what it is. Sometimes it just doesn't look as obvious when we're looking at things that tend to end up being more complicated later on.